This tiny piece of leather changes how people bleed in the Octagon. Welcome inside Diaco. One glove. Had to solve a problem fighters fear more than getting knocked out. Today we get inside the only factory building the new UFC 3-8 gloves. Stay till the end. We'll show you the single test that decides if a glove ever reaches the Octagon. We're following this glove from raw foam to the cage, and we're going to answer one question. How do you design a glove that lets fighters grapple without gouging an eye? For years, small open-fingered gloves were a fixture of MMA. They protected knuckles. They let fighters grip. But they also left eyes exposed. So the sport asked its equipment partners a hard question. Can you fix this without changing the sport itself? Would you trust a glove if you knew the old design was part of the problem? Here's the run. Raw foam and leather, palm molding, the finger channel, stitching and assembly, then quality control. It starts with foam that looks almost ordinary. This is layered impact foam, dense on the outside, softer underneath. Think of it like a car bumper. Rigid skin, absorbent core. Every sheet is measured for density before it's approved.
If the foam's off by even a little, the glove won't pass later. So we catch it here.
Remember that eye poke question? This is where the fix actually begins. Next, the foam goes into a heated press. Heat and pressure fuse the layers into one solid palm shape. No stitching yet, just heat and about 40 seconds of clamp pressure. A small change in that pressure can mean the difference between a glove that holds its shape for one fight or 100. This is also where the padding thickness over knuckles gets locked in, the part fighters actually feel. Here's the part they don't put in the marketing copy. Between each finger slot, there's a narrow raised ridge, just a few millimeters tall. It's molded, not stitched on. That ridge does one job. It keeps a stray finger from sliding straight out toward an opponent's eye. It sounds tiny, but engineers ran hundreds of hand position tests to get that ridge height right. We weren't trying to reinvent the glove. We were trying to fix one specific accident. This is the fix the whole video has been building to. But it only works if everything downstream, stitching, testing, holds it in place. If this peek inside the factory is surprising, hit like, and tell us in the comments which steps shock you most. We actually read them. Now the molded shell meets the leather outer layer. Most of this used to be hand-stitched. Now it's a hybrid. Machines handle the long, straight seams. Humans finish the curves by hand. Why not automate all of it? Because a machine can't feel when the thumb seam is a ½ millimeter too tight. Every glove that leaves this station still has a human fingerprint on it, literally. Now, the moment this whole video has been building toward. Every finished glove is clamped into a test rig. A calibrated probe pushes into that finger channel, simulating a grabbing, twisting hand. If the ridge deforms past its limit, the glove fails. Right now, that failure rate sits in the low single digits. Every reject gets pulled and logged before it ever ships. Why so strict? Because one bad glove in one fight undoes years of design work. We're not just testing a product here. If this fails in the cage, it's a fighter's eye. That's what keeps us honest. That's the test. That's what decides if a glove reaches the Octagon or gets sent back. So back to our question. How do you stop an eye poke without changing the sport? You don't add more padding. You don't cover the fingers. You add one small ridge. Test it until it holds. It's a reminder that most breakthroughs aren't loud. They're a few millimeters, tested a few hundred times. Honestly, I've been on this line 11 years. When you see a fighter tap their gloves together before a fight, most people don't think about us. But we do. Every stitch, every test. We know whose hands these end up on. That test rig back there, the one that rejects gloves, I built part of it. First year was running. We caught a batch that would have shipped bad. That's the part I'm proud of. If you like this look inside the factory, subscribe. We go inside a new factory every couple of weeks. Tell us what we should tear apart next. This is Factory Intelligence. See you at the next build.